Okay, so this is the foundation paper, question number 8. State why sodium is stored in oil in the laboratory. Okay, so sodium is a member of group 1. It's very reactive. It will react with air or moisture in the air, and therefore we keep it in oil. Okay, so it's to prevent reaction with air or moisture. Okay. Describe the change in appearance when a piece of freshly cut sodium is left for a few minutes. So when you cut the sodium, the inside of it is very shiny, but if you leave it for a few minutes, it begins to tarnish, which means it goes grey due to the reaction between the sodium and oxygen, making sodium oxide. Okay, so shiny appearance, quickly tarnishes. Okay. Give the formula of the compound formed when sodium reacts with oxygen. Okay, so in order to answer this question, it's a good idea to use your table of ions on the back. And we've got down the bottom here a description of sodium reacting with oxygen. So if we look at the table, sodium is Na plus and oxide is O2 minus. Okay, so we need 2 sodiums, each with a single positive charge, to balance or cancel out the oxide ion, which has got a double negative charge. And so the formula would be Na2O, because there's 2 sodiums and 1 oxide. So if we transfer that to our answer sheet, Na2O. Moving on, the diagram shows the reaction of sodium with chlorine. Okay, so it happens inside a gas jar with a combustion spoon, or deflagrating spoon it's sometimes called. And the molten sodium is produced by heating the sodium in a Bunsen burner flame before plunging it into the chlorine gas. Why is it necessary to carry out the reaction in a fume cupboard? Well, that's because chlorine is toxic. And if you breathe it in, it will be a very bad day. Okay, so chlorine is toxic, so it has to be done in a fume cupboard, which sucks the chlorine away if it escapes out of the laboratory. Okay, part 2, complete and balance the equation for the reaction of sodium and chlorine. Well, sodium will represent as a single box with an Na inside it. Cl2 we will represent as a box with 2 chlorines. And then we don't know what's going here. Okay, so again, we could refer to our table of ions, and we rediscover that sodium is Na plus, and that chloride is Cl minus. With that information in mind, we've got Na plus Cl minus. These two automatically cancel each other out. There's no need for additional sodiums or chlorides, and we end up with a formula of NaCl sodium chloride, which of course is common salt. So if we put NaCl here, and we represent that as NaCl, and then we have to ask ourselves, have we got the right number of each element on either side of the arrow? We've got 1 sodium here, 1 sodium here. It's a good start. It won't last. We've got 2 chlorines here, but only 1 there. So to make that balance, we need to add an extra sodium chloride, because that's the only thing that contains chlorine on this side of the arrow. And in doing that, we now notice that we need 2 sodiums, because we've got 2 sodiums here. So we've got an additional sodium there. And now, for that should be balanced. So to make the written version work, we need to put a 2 to represent the 2 sodiums, and a 2 there to represent the 2 NaCls we've drawn here. Okay. Now, this is a table about trends in elements. Okay, so if we have a look down the melting point, we'll notice that the melting points are increasing, as are the boiling points. The reactivity, however, is decreasing, because we start with explosive fluorine, and we end up with very slow reacting iodine. Okay, so if we have a look at the question, it says put a tick in the box next to the most likely boiling point for iodine. Okay, so we can see that the boiling points are actually increasing as we go down here, and the most likely one is 150 degrees Celsius. Okay, And then the final question says, astatine lies below iodine in group 7. State how you would expect astatine to react with hot iron. Give a reason for your answer. Okay, so astatine would be here. We can see that the pattern is generally, they're getting less and less reactive. So astatine barely react at all. Because reactivity is decreasing down the group. Okay, so that's question number 8.